This example is a question from the 2013 free response section of the AP exam. And it says here we have hot water dripping through a coffee maker filling a large cup of coffee. The amount of coffee in the cup at time t is given by differentiable function c. So c here is measured in ounces and t is in minutes, and we have values given in the table. So this first part of this says approximate c prime at 3.5. Well, first thing is we do not have a derivative, so we cannot find the exact value of the derivative at 3.5. However, this does say approximate, and we can approximate the derivative at 3.5 by taking the slope somewhere around 3.5. So 3.5 is here. And what we're going to do is we're going to take the slope between these 2 points. And that slope should approximate the derivative at 3.5. Okay, so we're going to say this is equal to approximately c of 4 minus c of 3 over 1 minute. So we have 12.8 ounces, and we're taking away 11.2 ounces. And that happens over 1 minute, so we end up with 1.6 ounces per minute. And it is important to indicate that this is, first of all, increasing. We need to make sure we keep track of the units. Okay, we're going to be given marks on that, and we know that this is at time 3.5. It's approximately at 3.5. Okay, that's also important that we know that this is happening at a certain moment. Part B says, is there time t between 2 and 4 where c prime is equal to 2? This problem is alluding to the mean value theorem. Okay, so this problem looks like it's alluding to mean value theorem. For mean value theorem, we need a condition that it is differentiable or smooth and continuous in that interval. So we have this interval between 2 and 4, and the mean value theorem is stating that the average slope between these 2 points should equal the instantaneous slope should equal the average slope at least once in that time interval. So let's test this. So the average slope is going to be is going to be 12.8 minus 8.8, and that's going to happen in a time interval of 2 seconds. So we end up with 2 ounces per minute. And so that is our average slope. The instantaneous slope is 2, so this is in fact true. We know that the instantaneous slope must at some point, because it's smooth and continuous, it must equal a value of 2 ounces per minute. So by mean value theorem, we know that c prime of t equals 2 at least 1 point. And that's going to happen in the time interval between 2 and 4 seconds. Part C says, use a midpoint sum with 3 subintervals to approximate the value of this integral. So first of all, we are given from 0 to 6, and we want 3 subintervals. So I can break it into 3 subintervals, and the height that we're going to use to calculate that area is going to be the midpoint sum. So the y value at 1, the y value at 3, and the y value at 5. So we can see it very clearly when we draw that out. So each interval is going to be 2 minutes, and for the first interval I'm going to use 5.3, so I'm going to end up with 10.6. This is, ounces times time. So the units are kind of awkward there. I'm going to find the next one at 3, 11.2, so we're going to end up with 22.4. And in the last interval, we're going to use a midpoint sum of 13.8, so we end up with 27.6. So the integral part of this is equal to, so I'm just going to rewrite this out, so 1 over 6, and the integral part of this is going to be this portion here, and that's equal to, when I add this up, it's going to be 10.6 plus 22.4 plus 27.6, and that is going to be the total area under that curve. Okay, and that, when I work this out, I'm just going to put this into my calculator here, 10.6 plus 22.4 plus 27.6, and gives me a total area of 60.6. So when I work this out, this is 60.6, and the units are actually ounces times time, but I'm going to divide by 6 minutes of time here. And when I do that, I'm going to end up with 10.1. Now this is the average value formula. We're trying to find the average value of C in ounces over the time interval t equals 0 to t equals 6. So this expression indicates the average value formula. Okay, and the average value formula is really the mean value theorem in the integral form. But this is the average value formula. So if you recognize that, we know that we're talking about the average value of C, and the units must be in ounces. Okay, lastly, the amount of coffee in the cup is modeled by this differentiable expression, B of t is equal to 16 minus 16 e to the negative 0.4 t. Now, you don't need to graph this, but when we do graph this, we get some graph that looks kind of like this, which is modeling the data that we had as well. And if I want to find the rate of change, I want to find the derivative. So this is b of t. What I really want is the derivative at t equals 5. So I want to know the slope at t equals 5. So I'm going to differentiate this expression. I'm going to end up with negative 16 e to the negative 0.4 t, use the chain rule, times my negative 0.4. Okay, so this ends up being 16 times, okay, so 16 times negative 0.4. I end up with negative, this ends up being positive 6.4 e to the negative 0.4 t. I want to know the derivative when t equals 5. Well, I just need to substitute in t equals 5. So I end up with 6.4 e to the negative 2. And that's approximately equal to, when I calculate that, 6.4 e to the negative 2. And that gives me 0.866. And this is going to be in ounces per minute. So we're increasing, and this is important, we are increasing at a rate of 0.866 ounces per minute at time equals 5. And this is important that we state the time, because that is part of the marking of AP. They want you to make sure that it's specifically at that time.